With all functions, we are generally interested in investigating their intercepts, the x and the y-intercept. That's no different with quadratic functions. Quadratic functions are going to often have intercepts. They will always have a single y-intercept, okay, because the graph is always going to open either up or down and out, but it always opens out, so eventually it's going to cross the y-axis. It will, however, vary in terms of how many x-intercepts it has. This graph that I just drew has 2 x-intercepts. But if you imagine having a parabola that's up above the x-axis, so the vertex is above the x-axis, it could have no x-intercepts. Or you could have a parabola that is just barely on the axis, only touches the axis in one point, and then it could have 1. So x-intercepts are a little variable with parabolas, but y-intercepts, you'll always have a single one. Now, we will investigate all of these situations further along, but we're going to look at first an example where you actually do have 2 x-intercepts. So let's start with this example, f of x equals x squared minus 4x minus 5. We're actually going to find x and y-intercepts exactly how we found them with lines, which is that to find a y-intercept, we're going to set the x value equal to 0 and solve for y. And to find an x-intercept, we're going to set y equal to 0 and solve for x. So let's start with the y-intercept. We want to set x equal to 0. So we take our equation, which remember f of x can also be called y, and put 0 in for x. Now the great thing about putting 0 in for x is it eliminates a lot of terms. The x squared term goes away, the x term goes away because they go to 0. So we actually just end up with the constant term. And in fact, the y-intercept in a parabola is always going to be that constant term. So the y-intercept is going to be at y equals -5, but specifically 0, -5, because we do want to remind ourselves that the x value is 0. For x-intercepts, we're going to do the opposite. We're going to set y equal to 0. Now this is a little bit trickier in terms of calculations because we end up with a quadratic equation instead of just a simple calculation. Remember, to solve a quadratic equation, we are going to use factoring at this point. And to factor this, we're going to look for factors of -5 that add up to -4. So we can set up our parentheses, x and x give me x squared. And if you think about it, -5 and a +1 will not only multiply by -5, but they will also add to -4. So we have a factorization here, and then we can set each factor equal to 0 using the principle of the zero product and solve for x. So x is equal to 5 or x is equal to -1. So what this is saying is that we actually have 2 x-intercepts. We have an x-intercept at 5, 0, and we have an x-intercept at -1, 0. So remember how I said an x-intercept, you could have 1, 2, or 0 of them. Here's an example where we have 2. We'll look later on in the chapter about how it works if you have 0 x-intercepts. But for now, the examples you're going to see are either going to be 1 or 2 x-intercepts.